So now we're going to talk about how we find the product or how we multiply complex numbers. And we talk about this thing that we call the conjugate. And when we're talking about the conjugate, the first thing we need to realize is that when we multiply the product of two complex numbers or in standard form, we're going to use our FOIL method again. So in this particular case, we're going to do A times C, which is your first, A times DI, which gives you the imaginary part, and then BI times C, or plus BCI, which is another imaginary part, and then you're going to get the BI times DI, which gives you BDI squared. And the most important thing we need to see here then is that we have this I squared term. And remember that I squared is always equal to -1. So essentially what we're going to get then is these two parts are going to be your imaginary part. And then this front term in the front is a real part. And this term in the back will also be a real part, but it's always going to change its sign because you're multiplying it by this -1. And so we developed this thing that we call the conjugate. And the conjugate of a complex number, A plus BI, its conjugate is A minus BI. Every conjugate comes in a pair. So you have A plus BI, and its conjugate is A minus BI. And when you multiply that, and here's what happens, you're going to get A squared, a negative ABI, a positive ABI, and then you get this B squared I squared. Well, notice this part are the exact same terms, right? So they're going to cancel, and you're left with A squared. And notice you have a positive negative makes it a negative BI here, but you're multiplying it by an I squared, and I squared always equals -1. So that's a negative negative. So literally what you get is A squared plus B squared. And this is today's shortcut if you want to use this shortcut. Just square the A term and square the B term and then add them. So let's look at an example. We have -4 plus 8i times 2 plus 7i. So we multiply it first. -4 times 2, outer, which will be plus a -4 times 7i, inners, which is a 8i times 2, and then your last terms, which is a plus 8i times 7i. So we clean this up. -4 times 2, that's a real part. Then you have -4 times 7i, that'll be a -28i. Then you have 8i times 2, that is a positive 16i. And now this back part becomes 8i times 7i is a positive 56i squared. Well, notice that you have this I squared term here. I squared is equal to -1. So it's going to always flip whatever this sign is. So what you have is -8. We can clean up the imaginary parts because they both have I, so we can clean them up. -28 plus 16i is a -12i. And this back part now becomes because you have the -1, this positive is going to flip its sign to a minus 56. And you get a real part now because I squared is just equal to -1. So adding the real to the real, the imaginary to the imaginary, we get -8. -56 is a -64 minus 12i. And so you have to be careful when you do this because you're always going to get this I squared in the back. Make sure you change the sign of whatever this is because you're multiplying that I squared to a -1. The next one says, find the product of 6 minus 9i is conjugate. So if you take 6 minus 9i, the conjugate just changes the middle sign. So you're going to get 6 plus 9i. Now, here's how we do this with FOIL. 6 times 6 is 36. 6 times a positive 9i is a positive 54i. 9i times negative 9i times 6 is a negative 54i. And then negative 9i plus 9i is a negative 81i squared. Well, notice that these middles are the same, so they're going to cancel each other out. And then back here you have I squared, which is negative 1, but you're multiplying it times the negative makes it a positive 81. So you get 36 plus 81, which is 117. Now, a quicker way to do that is to just square the first number, 6, and then add it to the back number, 9 squared, which is 36 plus 81, which is also 117. So when you're multiplying by the conjugate, you're always going to get a whole number. And the quicker process is to just square the first and square the last and just add them. That's the purpose of the conjugate. The conjugate wants to remove the I. So let's look at an example for division now. When we talk about division, the reason that the conjugate is so important is because in division, we have to use this process that we call rationalizing the denominator. You can never have an I term or a complex term in your denominator. And to eliminate that, we multiply by the conjugate. So what we do if we're going to multiply by a special form of 1, we're going to multiply the conjugate by the top and the bottom, which in terms means you're really multiplying by 1 and you're not changing anything. But we're going to rationalize this. So here's what I mean. Look at your bottom first. And you're going to multiply by the conjugate of the bottom, which is 4 minus 3i. Remember, the conjugate is changes the sign. But we're going to multiply the top also by 4 minus 3i. Realize that these are the same numbers. Because they're the same numbers, the same number over the same number equals 1. So you're just multiplying this by 1. But this works now because here's what happens. We're going to multiply the top using FOIL first. 6 times 4. 6 times negative 3i. I times 4. Negative I times the negative 3i is a positive 3i squared. So if we clean this up, remember, we can combine the I terms together. And remember back here, you have an I squared, which means a negative 1. And it's going to change that sign, so you're with 24 minus 3. And then minus 18 minus 4i is a negative 22i. And so when we clean that up, you get 21. 24 minus 3 is 21 minus 22i at the top. So the top is just 21 minus 22i. The bottom is you're multiplying the conjugate. So if you multiply the conjugate, all you have to do again is square the first number. That's 4 squared is 16. Square the back number. That's 9. And then add them. So what you get is 21 minus 22i over 25. And typically speaking, when we write this in separate parts, we will write this as 21 over 25 minus 22 over 25i, because you want to write the real by itself and the imaginary by itself. So same thing here. We can't have i's in the denominator, so we need to remove it by multiplying by the conjugate. Well, the conjugate of 6i is negative 6i. You change the sign. Top and bottom by negative 6i. So multiply that by that. Negative 4 times negative 6i is a positive 24i. Positive 5i times negative I is a negative 30i squared. Remember that I squared equals negative 1, so it's going to change that sign. So we write the real first. So this negative times the negative becomes a positive. So it's a positive 30 minus 24i. And then the bottom, you're just going to multiply, square this, and you get 36. And so when you do this now, again, write the real over the real, minus 24 over 36i. And we can reduce these fractions, actually. These have a 6 in common, so 30 divided by 6 is 5. 36 divided by 6 is 6, that's 5, 6. These also have a 6 in common. 24 divided by 6 is 4. 36 divided by 6, they actually have a 12 in common. Let's go further. They have a 12 in common. 24 divided by 12 is 2. And 36 divided by 12 is 3. And there's your final answer.